What I want to do now briefly is explain to you one of the dynamic forces of the sea, and we call this dynamic force wave refraction, which you can see in this diagram. Wave refraction occurs when a wave bends around a protruding headland. What is a protruding headland? Well, it's like a peninsula, like you see there right in the middle of this diagram. And if you look at the waves, you can see that as the wave energy is coming in, it indeed wraps around that protruding headland. If you look further out into the water away from the shoreline, you can see that the wave energy as it's coming in is more or less parallel, one wave to the next. However, as the wave gets closer to the protruding headland, you can see what happens, which is that the wave begins to bend and wrap around that protruding headland. So, when the depth of the water, of the oceanic water, or for that matter, the depth of a lake, equals 1/2 of one wave length, that is the distance from one crest of a wave to the succeeding crest. So half of that is half of one wavelength. When the depth of the water, in other words, how deep the water is, when the depth of the water equals 1/2 of one wavelength, what begins to happen is the wave begins to have friction with the ground, and it begins to slow down and then build up into what we, who live on the land, generally call a wave. Of course, most shorelines are irregular. They don't have this 90-degree angle where the waves come in straight away at a 90-degree angle and hit the coastline. Most shorelines are irregular. They have bays, they have protruding headlands, they're straight in some cases, they may be angled in other ways. In many cases, the offshore landscape mirrors the onshore landscape. Because sea level goes up and down over time, it would make sense that it would be this way. So if you have a piece of land that sticks out into the ocean, so too the offshore environment is going to look similar to that. It's also going to stick out, in other words, be shallower and stretch out further. Whereas if there's a bay, what's going to happen is the offshore environment is going to mirror the look of that bay. When the wave energy reaches 1/2 of one wavelength at different places, as it's going to do when you have an irregular shoreline with protruding headlands and bays, what's going to happen is the wave is going to begin to slow down in some places and continue full steam ahead at others. That causes the wave to wrap around the protruding headland, that sort of peninsula that sticks out into the water. This is what in surf lingo is called a point break. If you take one more look at this diagram, you can see that that is exactly what's happening. The waves, when they're further out away from the shoreline, as I said, are parallel to each other. As they come and get closer to the shoreline, you can see right in the middle that what's happening is the wave begins to bend. The reason it bends is because that area straight out away from that protruding headland is at a depth that's equal to 1/2 of one wavelength, whereas the water that's straight out away from the quiet beaches, the bays, is deeper. And so what that causes to happen is it causes the waves to wrap around the protruding headland, what we call in this business wave refraction.